Problem number 5. Jill is meeting a friend for lunch. She arrives at a random time between noon and 12:30 p.m. If Jack does not arrive within 15 minutes, she leaves. Jack is less patient. He also arrives at a random time between noon and 12:30, but he only waits 5 minutes for Jill before leaving. What is the probability that the two will eat together? Alright, now this is a tough problem, and the key to it is visualizing the problem, okay? We need a visual. And the key is to graph it, okay? So I'm going to draw a graph of I'm going to put Jill's arrival time on the x-axis, and I'm going to put Jack's arrival time on the y-axis. Okay, so Jill arrives somewhere between, we'll call this 12 o'clock. All right, so this is 12 noon. All right, and somewhere between there and 12:30. Okay, so that's her arrival time. And Jack also arrives somewhere between 12 and 12:30. Okay, so here's 12:30. Okay, and if we were to plot out the area, of the possible combinations of their arrival times, we'd get a rectangle. Okay, so I'm just going to draw some dotted lines here, and any of the points within this rectangle would be a possible arrival time of the two of them. Okay, the pairs. Okay, so Jill could arrive at, say, 12:15, which would be right here. All right, so I'm just going to put 12:15, and Jack could arrive, anywhere here, and the pair would be a possible combination of their arrival times. Okay, so this rectangle represents all of the possible combination of arrival times between Jack and Jill, but only a few of those combinations will result in them actually meeting up. Okay, so let's take a look at those, the possibilities of them meeting. Okay, so let's take, for example, if Jill arrives at noon. Okay, she arrives first, and then Jack could arrive as late as 12:15, and then they would have lunch. So I'm going to put a dot there. That's the latest that he could arrive. If Jill arrives at noon, the latest that Jack could arrive would be 12:15, that's the latest that he could arrive. If he arrives at 12:20, they'll miss each other. Okay. So let's look at another example. What if Jill arrives at 12:15? Then the latest that Jack could arrive would be 12:30, right? Because she's going to wait 15 minutes. Okay. So this is the case where Jill arrives first. Okay. So we're going to assume that Jill arrives first. Now there are some cases like if Jill arrives at 12:15, but Jack arrived first at 12 o'clock, then they'd miss each other because Jack's only going to wait 5 minutes. But we'll not worry about that yet. We're just going to look at the case where Jill arrives first. We'll look at that case first. And so if Jill arrives first, then essentially we can create a line. Let me draw another dotted line connecting these points. Okay, so as long as Jack arrives before this dotted line, then they'll meet up. Okay, so like for example, let's see, 12:05 is probably right around in here. Okay, so if that's 12:05. Jill's gonna wait for 15 minutes, so he could arrive as late as 12:20. So that should be represented on that line. That should be about 12:20. Okay. And again, you know, if she arrived at 12:10, then Jack could arrive as late as 12:25. So that's probably in there too. Okay, so this is the line. This is the latest that Jack could arrive. If he arrives over here in this region, then they won't meet because Jill will have already left. Okay. So now let's look at the case where Jack arrives first. Okay. So if Jack arrives at noon, he's only going to wait 5 minutes. So Jill has to arrive by this time here, which is probably what, 12:05. Let me see if I can write that in there. 12:05. Okay. She has to arrive by that time. Otherwise, she'll miss him because he only waits 5 minutes. And so let's look at another case. If Jack arrives at 12:15, then Jill would have to arrive by 12:20, which is probably, let's see, right around in here, right? And so let's look at the extreme case where, say Jack arrives at 12:25. Okay, so right around here, 12:25. Now Jill would have to arrive between 12:25 and 12:30. So the latest that she could arrive would be 12:30. So that's Jill's arrival time. So that's going to be right here. And again, we can just connect those dots like that. Okay. And this line represents the case where Jack arrives first, and this case is when Jill arrives first. Okay? So if you look at any of the points within this region between these two dotted lines, they're going to meet up. You know, take for example here at 12:10. As long as, so let's say Jill arrives at 12:10. So as long as Jack arrived between 12:05 and what is that, 12:25, they're going to meet up. Okay. So the region here, this is the region of the possible combinations of Jill and Jack's arrival times that will result in them eating lunch together. Okay? Anything out here in these two little corner triangles are going to result in them missing each other. Okay? And the whole rectangle is all the possible combinations of Jack and Jill's arrival time. Okay? So what we really need to do is just compare areas. Okay? So let's take a look at this. So we know the area of the rectangle, which is actually a square because it's 30 minutes by 30 minutes, right? So the area of the rectangle is what? It's just 30 times 30, which is 900. Okay? Now we need to figure out the area of this funny shaped thing. Now we could break it up into other pieces, but it's actually easier to figure out the area of these triangles where they don't meet and subtract it from the whole area, because those triangles are fairly easy to figure out because it's 12:05 to 12:30. So this length is 25 minutes and this length is also 25 minutes, right? Oops. So it's just 1/2 base times height. We know a height and we know the base, so it's this area here is just equal to 1/2 base, which is 25, and height, which is 25. Okay, and when we do that, it's what? 625 halves. I'm just going to keep it like that for now. Okay, and over here, here we have, this is 15 minutes and this is 15 minutes. Okay, so here the area is 1/2 15 times 15, and that's going to give you what? I'm running out of room here. So it's 225 over 2. Okay. So the area of the, so let me write this out. Area of shaded region, which is the region that we're interested in, is just going to be the whole thing, which is 900, minus 625 halves, minus 225 halves. Oops. Okay, 15 squared and 25 squared. Okay, so what does that give us? That gives us 900 over 850 halves, and so that's 900 minus 425, which is 475. Okay, so now the probability that they're going to meet is just the ratio of the area that they, the shaded region where they do meet, versus the whole rectangle, which represents all the combinations of all the possible arrival times. Okay, so if we take, so the probability is equal to the ratio of those areas, so that's 475 over 900. And we can reduce that down. I can see right away that they're both divisible by 5, right? So I think that gives me 95 over 180, and that can be reduced down even more, and that eventually gives me 19 over 36. Okay, so that's the probability that they will meet. And if you want to convert that to a percentage, sometimes it's a little easier to understand. That's about equal to 52.8%. So a little better than 50-50 chance that they'll meet. But so that's the probability that they'll meet. All right, 52.8, about 53% chance that they'll meet. If Jill only waits 15 minutes, Jack only waits 5 minutes. So there you go.